Okay, welcome to episode 2 of the Pygame top-down shooter tutorial series. In this one we will be doing player animation, we will also be giving the player a weapon and also implementing the basic enemy. So without further ado, let's get into it. So in order to make our player animations, essentially we are going to have a list of player sprites which we are going to iterate through. So these player sprites can be found in the link in the description. What you must do is download that, or you could alternatively make your own. But whatever you do, make sure that you put them in the same directory as your script and everything should work for you. So we're going to name this list player_walk_images is equal to pygame.image.load. And I have this named player_walk_0.png. That's the first one. But we have more than one image, so we're going to copy this. And we are going to paste it once. Then we're going to paste it again, and we're going to paste it one more time, and we're going to name this player_walk_1, player_walk_2, and player_walk_3. Okay, so these are all of the walk images that we're going to be using. Once again, these can be found in the description. Now, we're going to come into the player class, and this is where we are going to do our magic. So, we want each one of these images to display on the screen for 4 frames, and then go on to the next one. So what we're going to do is we're going to say self.animation_count, and this is going to start at 0, and then we're going to basically continuously add 1 to this, which is going to make it go to the next index of our array. So we're going to do that. What we're going to do is we're going to say come into our main loop, which remember this is running every time, well, 60 frames per second, because that's what our game's set to. So we're going to say self.animation_count plus equals 1. By the way, I'm using kite for these autocorrections. However, if we just continuously add 1 to this animation count, then we're going to eventually get an index error. So let's make so that our animation count resets if it gets to a certain point. So what we're going to say is if self.animation_count is greater than or equal to, and we have got 4 elements to our array, and since we want each of them to display for 4 frames, we're going to multiply 4 by 4, which gives us 16. And we also need a plus 1 to this. And then, if this is met, then we're going to reset self.animation_count equal to 0. Okay, so now we have our animation count resetting after it gets to a certain point. Now we actually need to display this to the screen. So what we're going to do is we're going to comment out this drawing rect thing, and instead we're going to draw an image. So we're going to say, the way we do that in Pygame is we say display.blit, and then we're going to say our list. But obviously we can't blit a list to the screen, so we're going to index self.animation_count, which basically means whatever self.animation_count, whatever it is. So let's say that self.animation_count is 0. Then we're going to take the first element of our array. But if self.animation_count is 3, then we're going to take this element of our array here. And then of course we need a location for that. So in this case, this is going to be just self.x and self.y. Okay, so now this should theoretically be working. So if we go ahead and run this, we have an index error. Oh, we forgot to. So in order to make it so that each of these images stay on the screen for 4 frames, we're going to do integer division by 4. So now if we go ahead and run this, we should see we have our player, and if you look closely, the player is really small right now, but we see that he is animated. So now the next issue is that our player is really small. So what we're going to do is on this image, we're going to use pygame.transform.scale, which essentially allows us to make images bigger. We're going to wrap brackets around this. We're going to make a new set of brackets, and inside here we're going to say what we want our new player, the size to be. So our player currently has a size of 16 by 21. So we're going to times those by 2. So we're going to end up with 32 by 42. Okay, now if we go ahead and run this, we should see that our player is a decent size. Now we can actually see him. But now the next issue is that he's not stopping moving when we are not moving. So right now I'm not pressing anything and he's still moving. So what we're going to do to fix this is we are going to add some new variables to the top here. We're going to say self.moving underscore right is equal to false, and self.moving underscore left is equal to false. Then we're going to copy and paste this, and we're going to put it at the bottom of our main function. Then we're going to come down to where we hand in for input. And here, when we're pressing A, we're going to be moving left. So we're going to say player.moving underscore left is equal to true. And if we're pressing D, then we're moving right. So we're going to say player.moving underscore right is equal to true. And the reason that we don't have to set these to false when we're no longer moving left is because we're doing that at the bottom here. So essentially, we're going to be pressing, let's say we're pressing D, then we're going to set moving right to true. Then up in our main function, we are essentially going to do some if statements here on our, to work out whether we should be displaying the player left or right. Then we're going to set both of them to false, and we're going to repeat that every frame. So then we're going to say if, so if we look now, this should all theoretically work. Our player by default is moving right. So we're going to say if self.moving underscore right, then we're going to indent that. So if we're moving right, we don't have to do anything. Aleph self.moving underscore left. Now we need to flip the player. So we're going to copy and paste this line. So what we're going to do to get our player to flip is here, we're going to come here and we're going to say pygame.transform.flip. And we're going to wrap our image around this. And then inside here, we're going to say true, false. And essentially what this means is that yes, it is true that we want to flip our sprite on the x-axis. And it is false, we don't want to flip our sprite on the y-axis. Now if we go ahead and run this, we will see that sure enough, our sprite is moving around the screen. And when we're moving right, our sprite is flipped right. And when we go ahead and switch and move left, our sprite is now moving left. Okay, but now there's another problem. If I'm neither going right nor left, our sprite disappears. So what we're going to do to work around this is we're going to say else. So if we're not moving right or left, we can copy and paste this line back in here. But instead of saying self.animation count integer division by 4, we're just going to say 0. So in this game, when we're neither moving left nor right, our sprite is going to default to just sitting on the right. Okay, so now this is working pretty well. Okay, so the next thing that we're going to add is a basic enemy. So the enemy that we're going to use is a similar one from the game that I'm actually working on at the moment, and it's going to be a slime. Once again, this slime comes with our pack. So we're going to make a new class, and we're going to call it slime enemy. And in our initiation function, we're going to pass in x and y. So you know the drill. Self.x is equal to x. Self.y is equal to y. Now self.animation underscore images. So these are the images we're going to use to animate the slime, is equal to pygame.image.load slime underscore animation underscore 0.png. Let's do this again. Copy, paste, change this to a 1. Then we can make a new line, change this to a 2, and I believe once more, changing this to a 3. Yep, okay, so these are all of our animation images. So next, what we're going to say is that we also, of course, need this animation count. So self.animation underscore count is equal to 0. Then self.reset underscore offset is equal to 0. So I'll explain that in a minute. Self.offset underscore x is equal to random dot rand range between -150 and 150. Self.offset underscore y is equal to random dot rand range between -150 and 150. And then we also have to come up here. Don't worry, I'll explain what this does just now. And we have to make sure that we import the random module, which allows us to grab random numbers. Cool. So I'm going to explain what all of these variables do as we go on. So let's make a main function. This is going to need self and display. Okay. Then let's just get our animation stuff out of the way. So once again, we want these images to display for 4 frames. And we have 4 of them. So if self.animation underscore count +1, so we don't get an index error, is equal to 16. Self.animation count is equal to 0. Self.animation is equals 1. Okay, so the exact same system we used for our player. Now, let's do the fun part, writing the AI. Oops. So what we're going to do is we're going to make this enemy come towards the player. So if I go ahead and open up Paint here. Okay, so if we imagine that this is our player over here and this is our enemy, we essentially are going to want our enemy to move towards the player. But it would be very bland if the enemy just moved towards the player and that's it. When it got to the player, it just did nothing. So what we're going to do is, say our player is at the coordinate 0, 0. Then instead of making the slime move towards the position 0, 0, we're going to add an offset to both the x and y. So let's say this becomes 10, sorry about the bad drawing, 10, 5 after we add the offset. Then the slime is, instead of moving towards the player, it's going to move towards 10, 5. And then every couple seconds, we're going to reset this offset. So it's going to be here, maybe here, here. It's going to be basically everywhere around the player. And the slime is going to be constantly moving towards these different points. And this actually makes for a really cool and pretty simple enemy with only a couple lines of code. So let's write that. So what we're going to say is if self.reset underscore offset is equal to 0, which essentially means, okay, it's time to reset the offsets for our slime to move towards. We're going to copy these lines. We're going to put them in here. Oops. Make sure these are indented correctly. Then we're going to reset self.reset offset. So self.reset underscore offset is equal to random.rand range between 120 and 150. So this is basically saying, okay, we're going to reset our offsets, then we're going to make our reset offset some big number so that this doesn't constantly happen. So we're going to wait between 120 and 150 frames before we reset the offsets again. Else, so if reset offset is not equal to 0, then we're going to say self.reset offset minus equals 1. So essentially this means just get closer. So when this gets to 0, we'll run this again. Otherwise, we just subtract 1. Okay, so now we have our offsets that are resetting every 120 to 150 frames. Now we're going to say, now we need to actually do the movement. So if player.x plus self.offset underscore x is greater than self.x minus display scroll 0. So this essentially means if we need to move right. So if our player plus their offset is on the right side of our position. So this is just, so self.x minus display scroll 0 is basically just our position. Then we're going to want to move right. So we're going to say self.x plus equals 1. Aleph, now we're going to copy this line, and we're going to say is less than, so this is assuming that we need to move left. So we're going to say self.x minus equals 1. Now, we're going to copy both of these if statements, and we're going to do the same thing on the y-axis. So we're going to say if player.y plus self.offset y is greater than self.y minus display scroll 1. So remember, display scroll 1 is the index for our y. Self.y plus equals 1. Otherwise, we're going to say, and we're just basically all we're doing here is just replacing all the x's and the zeros for 1s. So just make sure you get all of them. And this should work. So now all we have to do is display the slime to the screen at the appropriate position. So for that, we just say display.blit at the display. No, sorry, we don't need to pass that. Then we're going to say pygame.transform.scale, because once again the sprite's too small. Self.animation images, self.animation count, integer division by 4 again. Oops. Then we're going to resize this to 32 by 30, so that's basically just double what we have right now. Then we're going to say self.x, self.y, and then don't forget to apply our display scroll. So in this case, this is 0, and then minus display 1. Cool. Alright, so now our enemy class is done, for the time being at least. Now what we're going to say is we're going to make a new list to handle our enemies. Enemies is equal to a blank list, and then let's just put one enemy in this list for the time being. And we'll just make it start at the same location that our player starts at. Now we just need a handle for all of the entities in this list. So we say for enemy in enemies, basically just iterating through the list. We're just going to call the main function for our enemy. And I go more into depth into what this actually means in the first part of this tutorial series. So if you haven't watched that, I would recommend going and watching that. So if we go ahead and run this now, assuming I haven't made any, spelling errors. Where is that? There. Assuming I haven't made any silly errors, this should, sure enough, you can see we have the slime enemy who is going to be walking around our player. They have their animation. We can shoot, but that doesn't do anything right now. But, as you can see, as we're moving around, the slime is slowly following us. It's not ever getting too close, but it's always moving. And you could adjust these, like, to your, so if you want the slime to stay even further from the player, we could go ahead and double these. Actually, the reason this isn't working is because we're not putting in these 300s on the reset. We're only doing it for the start. Now, if we go ahead and run this, we will see that the slime, it tends to stay further from the player. So yeah, this is a pretty cool way of making an enemy AI without that much code, actually. So yeah. Okay, so the last thing for this tutorial series is that we're going to be giving the player a weapon. And what I mean by that is essentially we're just going to give the player a weapon sprite, which is going to rotate towards the cursor, and when we shoot, it's going to look like the bullets are coming from the gun rather than just from the player. So the first thing that we need to do is load in the weapon sprite. So we're going to say player_weapon is equal to pygame.image.load shotgun.png. That's what it's called in the files that you can download from the link in the description. And then we're just going to say player_weapon.set_color key. I'll explain what this does now. 255, 255, 255. This essentially just means remove all white from the sprite. So the sprite will have a transparent background. Now what we're going to do is inside of our player class, we are going to make a new function called define handle underscore weapons. This is going to take a self and a display. Cool. And inside here, we're going to need to get the mouse underscore x and the mouse underscore y. And that's going to be equal to pygame.mouse.get underscore pos. So what this does is it just gets the mouse pos and it puts the x into this variable and the y into this variable. Now the next bit of code, you don't have to worry about exactly what it does, but essentially it just calculates the angle at which our weapon needs to be drawn so that it appropriately lines up with the mouse, but you don't really have to worry about exactly what this code does. So we're going to say rel underscore x, rel y is equal to mouse underscore x minus player.x, comma, mouse underscore y minus player.y. Then we're just going to say angle is equal to 180 divided by math.pi multiplied by negative math.atan 2 rel y rel x. Then, okay, so this basically calculates the angle. You don't really have to worry about this. The math's a little confusing. Then we're going to say player underscore weapon underscore copy is equal to pygame.transform.rotate player underscore weapon to angle. And the reason we're making a copy of this is because if we are transforming this, if we are rotating this to the angle while we are blitzing it, then the results are really weird. Like the gun turns out all twisted. So we just have to make this copy first. So then we say display.blitz. Then we want to make sure that we're blitzing the copy, not the original. So this is already rotated. Then we're going to say self.x plus 15. Okay, so now this is basically just making sure that the weapon is centered on the player. Self.x plus 15 minus int, the int value of player underscore weapon dot get underscore width divided by 2. So this basically just makes sure that it's centered. So we basically just subtracting half of the width from the weapon, and this must be, make sure to be weapon underscore copy. Okay, then we need to do the same thing for the y. So we're going to say self.y plus 25. And you're going to have to, depending on the size of your sprite, you're going to have to fiddle around with these numbers. Minus int of player underscore weapon underscore copy dot get underscore height divided by 2. And then we're just going to make sure to put another bracket here. Now, if we go ahead and run this, we should see that nothing happened yet because we haven't actually called this handle weapons function. So we're just going to come below our animations and we're going to say self.handle weapons, and we're going to just pass in the display. And while I'm down here, we may as well get rid of this rect thing because we don't need it anymore. Now, if we go ahead and run this, we will see that we have the weapon and it rotates towards the player. We can shoot and the bullets look like they're coming from the weapon. Okay, so yep, we can shoot, but the bullets don't do anything yet. Yeah, and I'm pretty happy with how much we've done so far. Before we end, there's just one thing that I want to change, and this is something that Mousy Dev pointed out in the comments, and that is that instead of saying pygame.quit in capitals, we need to say it in lowercase with brackets around it. So now, if we go ahead and do this, we will see that the program will close properly when it closes. So yeah, thank you guys so much for watching this tutorial series. Hopefully it won't be that, hopefully it will be less than a month before the next one. I know a lot of you guys were asking for this, and I'm sorry that it was so delayed. If you want to go download the images, you could do so from the link in the description. Stay tuned, and I'll see you all next time.